Hello, welcome to ZTalk. Today's session, we're going to learn how do we deploy Kubernetes cluster on EKS, which is Elastic Kubernetes Service on AWS via Terraform. Stay tuned. Firstly, let me assume that most of you guys have had experience or at least heard of Kubernetes. So I will make the introduction part real quick. As we know, Kubernetes is the most popular orchestration solution to manage application containers. Kubernetes is configurable either on cloud or on-prem. The main difference, though, is that you will have to manage the Kubernetes cluster infrastructure on your own if it's hosted on-prem, which is kind of challenging. The cloud vendors make us life easier by providing their own Kubernetes PaaS service like AWS EKS or Azure AKS, which makes the Kubernetes cluster setup easy and quickly deployable. Here I listed out a quick summary of benefits you can get from any cloud vendors. Firstly, I'll use EKS as example. You will the same benefit applies to other Kubernetes service provided by other cloud vendors. All right. Firstly, EKS hosts the Kubernetes infrastructure across multiple AWS availability zones and frees users from maintaining Kubernetes control plane. What's more, infrastructure running on EKS is secured by default by setting up a secure and encrypted communication channel between worker nodes and endpoints. And applications managed by EKS are fully compatible with applications managed by any standard Kubernetes environment. All right. Here is a diagram that explains how does EKS work at high level. Because EKS takes care of managing the Kubernetes infrastructure, we do not have to worry about master nodes at all. We're gonna start with provisioning a EKS cluster and deploying worker nodes, and then have those worker nodes connect to EKS cluster that we provision. Then we're going to deploy our application onto the EKS cluster. It's pretty straightforward. Here I attached a typical Kubernetes cluster setup. It's composed of master nodes and worker nodes. Again, for EKS, we do not have to worry about master nodes at all. Here, I just want to walk you through real quick of Kubernetes components. Basically, worker nodes, or you call worker machines, are the host of application pods. They do the actual work. There are three key processes that must be installed on every worker that are used to schedule and manage application pods. There are container runtime, kubelet, and kubeproxy. Kubelet interacts with both the container and nodes and adds resources to the containers. And kubeproxy is responsible for forwarding the requests from services to pods in an intelligent way with low overhead. By the way, pods communicate with each other via services, which is sort of a load balancer that catches the request directed to the pod and forwards it to the respective pods. And when I was saying forwarding requests in an intelligent way, a good example is like if the application replica is making a request to a database, let's say, instead of randomly forwarding the request to any replica, kubeproxy actually forwards it to the replica that is running on the same node as the pod that initiated the request to avoid the network overhead of sending the request to another machine. Make sense? All right. Next comes to the master node. Master nodes act like a cluster manager to schedule pods, reschedule pods, monitor the cluster, and join new nodes to the cluster. When we interact with Kubernetes cluster via KubeCtl CLI, we are actually interact with API server that is hosted on the master node. And master reviews or requests and forwards this or requests to workers. There are 4 processes that run on every single master node that control the cluster state and worker nodes. There are API server, scheduler, controller manager, and etc. EKS takes care of them, so I don't have to explain them in detail. But if you're you can review the documentation if you want to understand more about what each process is doing. All right, I will attach the link of documentation in the description of this video. All right, time to demo. For this demo, we're gonna set up EKS using AWS CLI first, and then we're gonna figure out how do we automate this process via Terraform. Here is some preparation or setup steps listed out here. You can review. When we configure something new on Terraform, the best way to do it is that we manually test it or manually configure it on AWS console first to verify every step works as expected. And then we figure out how do we automate this process by Terraform, right? Otherwise, if we directly jump to Terraform config, it will be really hard for troubleshooting if something goes down. Like from the the error message or information returned from Terraform apply, that's gonna be challenging to troubleshoot where it's wrong specifically. So better to test it out manually first to make sure everything works as expected. Then we figure out how to automate it. That's the plan. So follow this plan. Let's deploy a Kubernetes cluster on AWS console first to make sure it works via AWS CLI, and then we move to Terraform. All right, cool. Followed by the step-by-step high-level instruction listed out right here in the PPT. There are a couple of preparations we have to take care before we move forward to deploy our first EKS cluster on AWS. Right? If you haven't done so on your laptop, you're gonna need to install Kubernetes CLI, KubeCtl. You're gonna need to install AWS CLI. You're gonna also need to install AWS IAM Authenticator. All right. So let me jump to my browser. Here I'm gonna share the link of install instruction of each of the components. So you're gonna install them one by one. Here, let's start with a KubeCtl. Select the instruction detail based on your OS flavor and follow the step. Is pretty straightforward, right? And once it's done, you're gonna move next to the AWS CLI, and because we're gonna use AWS CLI to deploy or create or EKS cluster. Like the plan I explained earlier, I'm gonna walk you through step. First, how do we deploy EKS cluster manually on AWS portal, and then we move forward to deploy a cluster on AWS CLI. So once we get familiarized that process and verify everything works as expected, then we're good to figure out how do we automate this process via Terraform. All right. Another component you need to install AWS IAM Authenticator. Right. So basically, EKS uses IAM to provide authentication to your Kubernetes cluster through this AWS IAM Authenticator for Kubernetes. All right. Again, follow the instruction based on your OS flavor. If you're using Mac, as I do here, always all of those components, the easiest way is via Homebrew. just search for this and install. So once everything is installed, go to your terminal and verify by firstly, let's verify the AWS IAM authenticator. Just typing AWS IAM authenticator help. There should be something returned. Same thing for KubeCtl. All right, and AWS. All right, so once you make sure everything works as expected, we're good to go to deploy our first EKS cluster. So let me jump to my console. For this demo, I'm gonna create the cluster under Ohio, which is US East 2 region. All right. So firstly, let's take a look at the VPC inside of this region. As you can see, there's only one out there, which is the default VPC. So normally for our real world use cases, we're gonna need to build our own VPC for our use case, instead of using the the default one, right? Again, you can create or build your own VPC from scratch on your own. Like you can configure the security group, you can configure the subnet, you can configure the internet gateways, you configure the route table all on your own. We already had demo for that via Terraform, right? Previously, you can do that. And another option, you can use Terraform module to make this whole deployment or configuration quicker. We also had a demo for that, right? Today, I'm going to show you another option. Basically, it's a service provided by AWS. It's called Cloudformation. Let's just search for Cloudformation. Here we go. So basically, Cloudformation speeds up cloud provisioning with infrastructure as code practices. Cloudformation gives you an easy way to model a collection of related AWS and third-party resources, provision them quickly, and manage them through their life cycles by treating them as infrastructure as code. All right. So for this demo, I'm gonna show you real quick how do we use Cloudformation. Basically, it's the templates. So I will use Cloudformation to create a custom VPC for our Kubernetes cluster. So here you need to create your stack. So here you can create your own templates, or you use the templates available on the website. Some other developers shared, or the templates provided by the AWS documentation. So here I'm going to use the templates provided by the EKS documentation. Here we go. You can see create a VPC for your Amazon EKS cluster. So it gives you options, public and private subnets, only public subnets or only private subnets. That's also going to be the configuration options you will select when we configure the EKS cluster. So for this case, I'll just pick only public subnets. Let's use this template. All you need to do is just copy this URL, the URL of the templates, and go back to your Cloudformation stack and paste it right here. And click next. Give a name for your stack. I'll call it Kubernetes. All right. And as you can see down here below is the configuration comes out of that template. Is already configured the CIDR range for each of the subnets, right? And click next. I will leave everything else as it is. So click next and click create stack. Right, simple as it is. So all we need to do is wait these process being completed. As you can see here, is create in progress. You can monitor the status by clicking resources. With this process going forward, there will be more resources being created down here. Right now, is already created the internet gateway, and VPC is being created. And if you refresh, there will be more. You see here, the route table, subnets, all of that. It will take some time based on the customization. Like for this one, this default one, it will take, I'll say, like 5 minutes or so. So let's being patient and wait this process being done. All right. So while we're waiting, and you can see here, there's more coming. Right. So while we're waiting, there's another preparation we have to take care. Let's jump over there. So as I mentioned here, for AWS IAM Authenticator, as you can see, EKS uses IAM to provide authentication to your Kubernetes cluster, right? So before we create our first EKS cluster, we have to create the IAM role for our cluster, right? So let's jump to the IAM, which is identity and access management. All right, so what we need to do, we need to create 2 roles. So if you click roles, as you can see, already create the 2 roles related for EKS. One at AWS service role for Amazon EKS, and the other is this guy. So I'll show you how do we create it. So you just click create role button right here, and the first role, you choose the use case, right? So choose use case as EKS right here, and the first role is going to be EKS. So as you can see the description, this role or this use case allows EKS to manage clusters on your behalf. You're going to need that. So click that, go next, go review and create role, right? So once it's done, you will see that back here. Roles, and this is the one for that role. All right, another role is gonna be create role, and in this case, again, the use case still EKS right here, and this time you're gonna select EKS cluster. This use case allows access to other AWS service resources that are required to operate clusters managed by EKS. All right, so click that, go next. Here, by the way, if you want to review the policy, so here, this is the JSON format, policy detail, right? And go next. Go review. You're gonna give a name of for this role. So in that case, I already I call it EKS admin. So create that once you give a name, and I will show you here back to my AM console roles. Here we go. This is the role. Basically, this is the role we're gonna use when we configure the EKS cluster. All right, that's pretty much it. So once we take care of the IAM, all we need to do is we wait for the VPC get ready. Then we're good to jump to the EKS cluster configuration. All right. So let's take a look how it goes so far. Let's jump back to Cloudformation. All right. You see the VPC is ready, so the status is already green, showing green, right? So let's verify that by going to VPC and click that, and here we go. As you can see, there are 2 VPCs out there in the Ohio region. Click inside of the VPC. As you can see, this is the new one just created by the Cloudformation service. All right. here you can review the detail. This is the CIDR detail. All right, looks good. And here you can also check the subnet. This is basically I select the public only subnet, right? So there are 3 public subnets available for our cluster. Then we're ready to move forward. So let's go to EKS Elastic Kubernetes Service. Right. So let's create our first EKS cluster. Let's start from here. So give a name. I will call it zztalk-eks-demo. Next. All right. I will use for the regarding the Kubernetes version. I'm going to use the default, which is 1.21. And as you can see here, the role has been already discovered right here. This is exactly the role we just created under IAM, right? And I will leave the rest as it is and go next. And as you can see, the next page will be networking configuration. So we had a VPC, custom VPC created for EKS. So let's select that, this guy. Right, and as you can see, there are 3 subnets available under this VPC. And again, so for the cluster endpoint access, because our VPC, I select the template as all public only subnets, so we're going to choose public. And the rest, I will keep the rest as it is. Go next. Here, you have some logging options for your control plane. Basically, those are the components I talked about on the PPT. Remember those API servers? These basically are the key processes running on the master node. It will be good for your if you're configure your production environments, your real environments. Will be good to enable some logging for those control plane processes to monitor that, to make sure they're acting or performing as they are supposed to do. But for this demo, I will keep everything disabled, right? Go next. And click create. All right, that's pretty much it. You can see how easy it is, right? So all we need to do, we just need to wait these cluster being created. Right now it's showing still creating. It will take some time. And once it's done, we're ready. That's basically the procedure, how we do that manually on the AWS console. So once it's done and we make sure it's working, then we can, next step, I'll show you how do we deploy the cluster via AWS CLI instead of console. And then, as planned, once we make sure that works as well via CLI, we can go ahead to figure out how do we automate this process via Terraform. Sounds good? All right. Let's wait for this being completed. All right, it's done. As you can see, the status showing green, active. So let's go inside of this cluster to see what's going on. And because I haven't created any worker nodes to connect to this cluster yet, so you won't see much going on. So basically, all you see is comes out of box like this. But it's already good enough to get you familiarized how do we create the EKS cluster manually on AWS console. So next, I'm going to show you how do we do these things instead of from a console. How do we deploy the cluster via AWS CLI? All right, cool. All right, next I'm going to show you how do we deploy the EKS cluster via AWS CLI. It's going to be even easier than console. It's just the one command. But the prerequisites or prepare work that has to be done before we deploy the cluster are exactly the same as what we have done over the AWS console. We're gonna need a role created for Kubernetes cluster, and we're gonna need a VPC to host our Kubernetes cluster, right? So I'm not gonna repeat that prep work again. So I'm gonna use what we have already in place, right? So we already created that role for the EKS cluster, and we already had that custom VPC for Kubernetes that was created via Cloudformation, right? So I'm gonna use them for the demo. So let's jump to the IAM here and click roles, and this is the argument we can need shortly in the command role-arn. We're gonna copy this string, and let's jump to the terminal. And here, this is the command, AWS EKS create cluster, and you're gonna give the name of the cluster. I'll call it zztalk-eks-demo, and region, you're gonna define where these cluster will be hosted. Again, I'm gonna use US East 2, the Ohio region, right? And here we go. This is the argument. We're gonna need that string we just copied from the console. Role-arn, and you're gonna copy the string right here. And after that, the next argument will be resources-vpc-config. So regarding that configuration, we're gonna need the security group IDs, and we're gonna need the subnet IDs. And that's go to the Cloudformation where the VPC was created, where we can grab the information right here. So click that stack and enter outputs. This is all we need, the value for security groups key and subnets key. So firstly, let's start with subnets. So copy all of these subnets. Remember, these templates created 3 public subnets. These are the subnet string for that 3 public subnets. All right, copy them and switch back to the console, and argument resource -vpc -config and subnet IDs. You're gonna paste that string after subnet IDs, all right? And then put a comma. The next argument you're gonna need is security group, right? Security group IDs. And so switch back to the Cloudformation. Here we go. This is the string for security groups. So go back and paste right here. Then hit enter. All right. So as you can see, this is the JSON to show you what the configuration looks like for the new cluster we're creating, right? The name, the ARN, the version, all of that. All right. The cluster is ready. As you can see, the status showing green, and that's the cluster we just created via AWS CLI, right? So let's go inside of it to verify, and just click networking, and you can see it's using the VPC we created via Cloudformation. And we can verify here by like 765A, right? So go to the VPC, and this guy, the VPC ID is 765A, right? And the subnets, there are 3 public subnet, like E55E, 8388. So let's go back to the cluster and E55E, right? 8388, right? That's looks good. So we can also verify the status of our cluster from the AWS CLI, right? So let's go here, just run these commands, AWS EKS, and put the region is which is US East 2, and describe cluster, and sorry, there's the typo. So describe cluster, the name is zztalk-eks-demo, and put a query argument, put a cluster status, so hit enter, and see here, it's showing active. Right, same thing. Right, once it's done the next step, so you need to update your EKS cluster configuration to the KubeCtl file on your machine so that you can get access to these cluster via KubeCtl Kubernetes CLI, right? So you just need to run AWS EKS, again, region, which is US East 2, and run update-kubeconfig, right? And name will be the name of the EKS cluster, which is zztalk-eks-demo. All right, and you will see updated context. This is the ARN of our EKS cluster, so you can verify back to the console, but this is the one, right? And now you should be able to get access the cluster via the KubeCtl command. Again, here is the Docker Kubernetes. You can see it's already pointing to the cluster we just built, right? So you can run like KubeCtl get let's say namespace. Here we go. That's the information came out of that Kubernetes cluster. All right, looks good. All right, we got our EKS cluster up and running. Everything looks good so far. But if we issue KubeCtl get nodes, as you can see here, it returns no resources found. Well, as I explained earlier, that's because we haven't configured any worker nodes to connect to these Kubernetes cluster yet. As I explained, the responsibility. So what AWS EKS is responsible for is master nodes only. But regarding worker nodes, like how many worker nodes would like to connect to this cluster, that's really on our own. We have to configure those ourselves. So that's basically what we're gonna do in the next step. We need to spin up a couple of worker nodes and hook them up to the Kubernetes cluster that we just built. All right. Same thing. Let's do it from the AWS console first. Then we switch to CLI and get familiarized that process. Then we can get ready to figure out how to automate this process, right? So let's jump here again for creating worker nodes. I'm still gonna use the Cloudformation. So let's jump to the Cloudformation here, and all right. So let's do a new stack. This time we're gonna use the existing templates to spin up a couple of EC2 instances as the worker nodes. All right. So I'm still gonna use a existing templates that's shared in the S3 and go next. Here, let's give a name. Let's call it Kubernetes workers, and the cluster name will be zztalk-eks-demo, and the control plane security group. Here we go. And the worker node configuration, let's give a name, node group name. Let's call it EKS zztalk-eks-nodes. All right. And the minimum size of the node group will be 1. That's fine. And for this demo, we don't need too much for auto scaling, so I will change the default 3 down to 2. Same thing for the max size as 2. And I would select a smaller instance type. I will go with t2.micro, right? And key names. These key name is the EC2 key pair to allow SSH access to the instances. Here, you can create a key name. If you haven't done so, you can create a key name from console. Let me show you how to do that. So you just go to the EC2 instance, and under EC2 instance, you see there's the network and security section. Click key pairs, right? So you just need to create a key pairs, give a name. So once it's done, it will generate a private PEM file. That's your private key. It will be downloaded to your local. All right. So keep that file safe on your local. All right. Here, as you can see, I already create a key pair. It's called EKS. So I'm gonna use this one for SSH. So let me go back to Cloudformation and select EKS, and the network configuration I'm still gonna use the VPC that was just created by Cloudformation, this guy, and those are the 3 subnets comes along with the VPC. Next, this page I will just keep the configuration as it is and go next, and acknowledge that AWS Cloudformation might create IAM resources and just create a stack. All right. So again, these process will run for a while, but after it's done, we are expecting to see 2 EC2 instances spinning up. Let's wait for it. We can check the status here. Refresh. Okay, it will take a little bit of time. Meanwhile, we can open another tab. So go to instance. So we should be expecting to see 2 instances up and running right here. All right, let's give it a little bit of time. Okay, the process is done, and as you can see, this Kubernetes Walker stack is complete, showing green here. And what we're expecting, we should be expecting 2 Walker nodes or 2 EC2 instances up and running. So let's verify that by switching to the other tab. Go to instance and refresh. Here we go. There are 2 Walker nodes up and running. Looks good. All right. So now let's switch back to our terminal. Run the KubeCtl get nodes one more time. Okay, it's still showing no resources found. Yeah, that makes sense. Because we configured to spin up 2 Walker nodes or EC2 instance, and they're up and running right here. Right, we just verified, but we haven't configured these 2 Walker nodes to connect to our EKS cluster yet. That's why it's still showing no resources found. For connecting the Walker nodes to our EKS cluster, we need to do something more. We're gonna need to create a config map and apply that config map to our EKS cluster. This is how we're gonna do that. Here, in the documentation, it's already provide the configure map framework. You can just download by run this curl command right here. Again, I will share this command in the description of the inside of the video, right? And copy that and open it up. I will open up by Visual Studio Code. It's pretty simple. You can see the type of this YAML file is a config map, and the name of this config map will be called AWS auth, and this config map will be stored under kube system namespace. So that's basically come out of the box. What really we need to update is this role-arn. That's basically we need to copy the string, the ARN string from the Cloudformation here under outputs, node instance role. This is the string we need to copy and paste over there. Sorry, go back to the copy again and paste right here. All right, save it. And then we just need to apply these config map to our cluster by KubeCtl apply a file with -f as I'm gonna apply a file, and the name of the file is AWS auth cm. Hit enter. All right, as you can see, the config map was created. So let's verify that by KubeCtl get config map under kube system. Here we go. And you can see there was the config map created like 15 seconds ago. That's what we did just now, right? And now if we issue KubeCtl get nodes one more time, we should be able to see the two Walker nodes connect to or reporting to our Kubernetes cluster right here, right? Here, right now, the status is showing not ready. Let's give it a little bit of time. It should be showing ready real quick. Yeah, see, they're ready. Now our cluster infrastructure is done. So we got Walkers connect to our cluster. We're ready to deploy our applications to our cluster. Cool. All right, let's call it here before we move forward to figure out how do we automate this whole process via Terraform. I want to step back a little bit to review what we have done so far in this demo to again get familiarized the procedure. How do we deploy a EKS cluster, right? So here I list out the step-by-step what we have done so far. We started with some prep work to install like AWS CLI, KubeCtl, AWS IAM Authenticator to our local, so that we will be able to communicate with AWS and EKS cluster shortly, right? And then we start our real procedure for deploying EKS cluster. We start with creating roles that is required for EKS cluster, and then on IAM, right? And then we used a service called Cloudformation to provision the custom VPC to host our EKS cluster, right? So after that, we tried to create an EKS cluster using both AWS CLI and AWS console manually, and all worked just fine. And then we figure out the EKS cluster is up and running, but there's no Walker nodes reporting to that EKS cluster. That makes sense because, as we understand, the EKS service only takes care of the master nodes, right? But how many Walker nodes should be connected to these cluster is really up to us. We need to manage, configure on our own, right? That's then we start the next step to using Cloudformation again to provision EC2 instance or the Walker nodes for our EKS cluster, right? Once that EKS cluster, once those Walker nodes up and running, And the next step is map those nodes to our EKS master nodes, right? By creating that config map and apply that config map to the EKS cluster. And after that, we issue that KubeCtl get nodes again. We confirmed the worker nodes are reporting to the EKS cluster. That's pretty much the whole procedure. Let's please play with it or test it out on your end. Not just watching what I've done here. Is practice and practice. That's the most important or the easiest way to get you familiarized the procedure. And in the next session, we're gonna continue on this topic to figure out how do we automate this process via Terraform. All right, stay tuned, and I'll see you next week.
All right, thank you for watching my video. If you think this video is helpful, you're more than welcome to leave any comments. Remember, thumb up, subscribe my video, and also hit the notification bell. See you next time.